If humanity were to suddenly disappear today, would a civilization arriving on Earth hundreds of thousands of years from now be able to find even a single trace of us? And if almost no evidence remained, how likely would it be to discover the traces of a civilization that existed before us? This question occupies the minds of two scientists whose research converges on a single point. If humanity were to vanish, what would remain of us on a geological timescale? After years of study, this thought experiment, later inspired by the Silurian species from Doctor Who, comes to be known as the Silurian Hypothesis. While examining how humanity might leave a detectable imprint for future civilizations, Adam Frank and Gavin Schmidt also raise a far more unsettling possibility. What if we are not the first advanced civilization on this planet? Compared to Earth's 4.5 billion year history, humanity has existed for only about 300,000 years, temporally insignificant, yet extraordinarily powerful in its ability to transform the planet through megacities, global industry, and satellites filling Earth's orbit. And still, nothing on Earth, or in the universe, is permanent. Just as a meteor abruptly ended the dominance of dinosaurs that ruled the planet for millions of years, the end of the human species could arrive just as suddenly and unexpectedly. Even if we see ourselves as an advanced civilization, would any recognizable trace of us remain in a world shaped by technology? And if another civilization were to arrive on Earth in the distant future, would it find any evidence that we once dominated this planet? These are the questions that begin to take shape in the thinking of Adam Frank and Gavin Schmidt. The two scientists embark on a long-term investigation, examining how human activity alters the planet's geographical, chemical, and physical systems, and how nature erases these marks once human influence disappears. Their work leads them to a central conclusion. Any civilization that reaches a certain level of development shares one defining trait: an intense and continuous demand for energy. For a developing civilization, the most accessible energy sources are typically carbon-based. As seen in human history since the Industrial Revolution, the intensive use of wood and fossil fuels triggers profound changes in a planet's atmosphere, increasing carbon-12 levels and disrupting the delicate balance of carbon-14 and other gases. Under normal conditions, Earth's atmosphere gradually restores equilibrium. However, the signatures of these gas imbalances can be preserved for millions of years in layered ice and rock. Because humanity has learned to read these natural archives, deep ice and rock drilling allows us to reconstruct atmospheric changes spanning millions of years. Now imagine humanity vanishing overnight and an advanced extraterrestrial civilization discovering Earth by chance. Upon arrival, the first thing they would likely encounter is a quiet, seemingly untouched world. Even the great megacities of the past, New York, Tokyo, London, would eventually vanish, leaving no visible human structures behind. Human-made constructions do not last for hundreds of thousands of years. Within just a few tens of thousands, metals corrode, roads are overtaken by vegetation, and even the most durable buildings are swallowed by nature and erased in silence. In fact, even today, while we still inhabit the planet, much of our ancient past has already been reclaimed by nature. Archaeologists estimate that roughly 75% of the remains of ancient Egypt still lie buried beneath desert sands, while vast cities in South America that once housed millions are now almost entirely concealed beneath dense forests, civilizations that once believed themselves eternal. Despite this, we struggle to detect even these remnants today, because Earth constantly reshapes its surface. Rocks that were once seabeds become mountains, only to break down again over time. Through plate tectonics, Earth's surface is renewed again and again across immense timescales. As a result, although the planet is 4.5 billion years old, most of the ocean floor is only a few 100 million years old. This is why surface traces of very ancient civilizations rarely survive. An extraterrestrial visitor might find almost nothing on the surface, but the picture changes when subsurface layers are examined. By drilling deep into rock and soil, such a civilization could detect a sharp rise in atmospheric carbon-12 approximately 100,000 years ago. While similar fluctuations can occur through natural processes like volcanism, the human signature stands out because it reaches extreme levels over an unusually short time. And this signal is not limited to carbon alone. Nitrogen compounds used in agriculture and rare metals tied to advanced technology also show dramatic changes concentrated within the last century. From these clues, extraterrestrial observers could infer that a technologically advanced species once existed on this planet, one with an immense and sustained demand for energy. The conceptual framework developed by Adam Frank and Gavin Schmidt thus becomes not only a way to understand Earth's past, but also a powerful tool for searching for evidence of past civilizations on other worlds. To refine this idea, the researchers extend their work beyond climate models, continuing to study Earth's history through deep drilling data and geological records. In the process, they unknowingly approach a striking possibility. Deep geological data reveal an even sharper carbon-12 spike than that produced by modern humanity, dated to approximately 56 million years ago. Although powerful natural events such as supervolcanic eruptions initially seem like plausible explanations, detailed geological and geographical studies reveal no definitive evidence of such activity during that period. More intriguingly, not only carbon, but also surface metal concentrations and abrupt global temperature increases, phenomena difficult to explain through natural processes alone, appear in the same time frame. Still, none of this proves that a human-like advanced civilization existed at that time. It remains possible that an as-yet unknown natural process caused these changes. And because roughly 56 million years have passed, finding direct evidence of any civilization from that era is nearly impossible. To grasp this, imagine all human industrial activity suddenly ceasing today. Within just a few million years, Earth could largely rebalance its atmosphere, oceans, and surface, erasing most traces of our impact. Indeed, despite experiencing 5 mass extinctions far more catastrophic than anything we can easily imagine, Earth has repeatedly managed to restart the cycle of life. It is thought that Earth will retain this regenerative capacity for nearly 2 billion more years, until the sun's gradual brightening pushes the planet into conditions hostile to life. Taken together, these ideas raise the possibility that not only 56 million years ago, but perhaps much earlier, or even more recently, civilizations entirely different from humanity may have existed on this planet. As advances in archaeology, geology, drilling, and analytical technologies allow us to probe ever deeper into Earth's layers, we are, in effect, peering further into its past. And perhaps one day, we may uncover a well-preserved relic of a long-lost civilization, allowing us to understand our planet's deep history far more clearly than we do today. And the real question is this: has Earth already erased all of its secrets? Or have we simply not been looking in the right place?